We are going to look at atoms and the states of matter. Now, to start with an atom, we define an atom as the smallest indivisible particle of an element. Let's say, for example, I'm talking about the element oxygen. The smallest indivisible particle is what we call an atom. From that definition, it means that an atom can't be divided further. But from what we know is that an atom has got different parts, so many that it can be divided actually. So what are the basic parts of an atom? An atom is going to have the center, which is the nucleus. So here, this is the nucleus. And then now you need to know what is contained in the nucleus of this atom. Apart from this, you also have shells. These are the important components of an atom, the shell. Now an atom is going to have different shells. They are actually unlimited. An atom has got a lot and a lot of shells. But when you are dealing with chemistry, you only show those shells which have got electrons. Okay, so what is contained in the shells are electrons. Okay, this is what we are going to find in the shells. And then in the nucleus, there are two things that you are going to be able to find. You are going to find protons. You are also going to find neutrons. So altogether, the basic parts that makes up an atom, we have got protons, neutrons, and electrons. And their location, as you can see here, protons are found in the nucleus together with the neutrons, while electrons are going to be found in the shells. Okay, that is important to remember. Now, you need to know the properties of these parts of an atom. The protons inside the nucleus are positively charged. And then the neutrons don't have any charge, so we'll just use 0. They don't have any charge. While the electrons that you are going to be able to find in shells are negatively charged. Okay. There are electrons and they have got a negative charge. You also need to know the mass of the parts of an atom. Do you know the mass of an electron? Okay, so let me write a table. Here we are going to have protons, we are going to have electrons, and then we are going to have neutrons as a part of an atom. Now starting with, so I'm going to talk about their charge and also their mass. Okay, so starting with charge, as we have said, protons are positively charged, electrons are negatively charged, and then neutrons don't have any charge. They have got a charge of 0. Where are they found? Their location. Protons are found in the nucleus. Electrons are found in the shell. Neutrons are also found in the nucleus. And then, how about their mass? The things which are found in the nucleus are heavier than electrons which are found in the shells. So the mass of proton, we say that its mass is 1. Same with a neutron. Remember, these two are in the nucleus. Its mass is also 1. But the mass of an electron is given as 1 divided by 1840. Make sure that you know this, alright? So these are the masses. So the meaning of this is that an electron is way much lighter in comparison to protons and neutrons, which are very much heavy than the neutron. Okay, very important. Again, the number of protons in an atom is known as proton number. The other term for proton number is atomic number. So if you hear they ask you to say what is the atomic number of this atom, they just mean how many protons does that atom have. Now, for an atom, the number of a neutral atom, and what I mean by neutral atom is that an atom that hasn't reacted, it isn't reacted with anything. The number of protons and the number of electrons are going to be the same. It's very important for you to understand that. Okay, so what we are saying is a neutral atom. And what do I mean by neutral atom? It hasn't lost electrons nor has it gained electrons. That atom is going to have electrons and proton numbers being the same. Neutral atom. Let's give an example. For example, if you look at sodium, now when you're writing an atom, you are going to have A and Z. A is the proton number, all right? Actually, when you are writing Z is what we represent as the atomic number. What is the atomic number? It's the number of protons. So that is going to be Z. And then A is going to be the mass number. So for an atom, how do you calculate the mass number before I talk about neutral and everything? Let's say we have got an atom like this, and then in the nucleus, say you have got 7 protons, and then you have got 6 neutrons. You have got something which is known as the mass number. The other term for mass number is nucleon number. So the mass number or the nucleon number is given by the number of protons plus the number of neutrons. Remember, these are the things which are in the nucleus. So for this one, 7 plus 6, that is going to give us 13. This is going to be the mass number of this atom. If this atom is neutral, since we have got 7 protons in the nucleus, it means that also the electrons are going to be 7. So for a neutral atom, electrons is equal to protons. That is very important. So what happens is that when an atom is reacting, what is involved in a chemical reaction of an atom is electrons. This is also very important to understand. Protons are not involved in a chemical reaction. Neutrons are not involved in a chemical reaction. Those things are found in the nucleus. What will be involved in the reaction are electrons, which are found in the shells. And to be specific, when an atom has got different shells, so depending with how many electrons it has, you are going to show how many shells it's going to also have. Okay, so how do you find how many shells an atom is going to have or an energy level is going to have? So to start with, When you have got only one shell, the number of electrons is given by 2n squared. N here is representing the shell. Let's say we're talking about n is equal to 1. That is the first shell. How many electrons can the first shell have? So the first shell is going to have 2 times 1 squared electrons, and that is only 2 electrons. And then for the second shell, n is equal to 2. The number of electrons that the second shell is going to have is going to be 2 times 2 squared. 2 squared is a 4. 4 times 2, that is going to give us 8. For the third shell, the number of electrons it's going to have is going to be 2 times 3 squared. 3 squared is 9. 9 times 2, that is going to be 18. And it continues to go like that. Okay? So that is how you find the number of electrons. Now, this is representing the maximum, the highest number of electrons that you can have. It doesn't mean that the first shell can't have 1 electron. It can have 1 electron, it can have 0 electrons, or it can have 2. But it can't have more than 2. The second shell can have 6, 7, 5, 4, but it can't have more than 8. The maximum it can have is only 8 electrons. That is important to take note. Okay. Now, do you have any question here? Okay, good. Another thing that you need to understand about these shells is when you go on your periodic table, the periodic table is something like this. You are going to see the periodic table something like this. You are going to have hydrogen. Hydrogen can be placed here, or it can be placed somewhere here, but let me put it there. And then you're also going to have helium here. So on the periodic table you have got groups and periods. So group 6 will be moving from left to right. Those are going to be referred to as groups. So what groups do you have? You are going to have 8 groups on the periodic table. Group 1, group 2, group 3, group 4, group 5, 6, 7, and 8. Now, when you are going down, going in this direction, you are going to be having periods. You are going to have period 1, period 2, period 3, period 4. Each one of these, when it comes to an atom, there is something that they are going to represent. Okay. So for example, the groups, remember groups are those on top. The groups are going to be representing electrons in the outermost shell, while periods are going to be representing how many shells that atom has. For example, let's say we are talking about oxygen. Let me try to show. Hope this is good enough. So when you're counting the periods, the first period is this one, where helium and hydrogen is. So meaning that those only have one shell. And then the second period is going to be somewhere here. That is going to be period 2. And that is where you are going to find oxygen. Now oxygen is in period 2, group 6. So it is in group 6 on top here. What is the meaning of this? Period 2 means that oxygen has got only 2 shells. So when you're writing oxygen, it's going to have the first, let's say this is the nucleus, which has got protons and neutrons. And then it's going to have the first shell and then the second shell. These are shells. And how did we tell? it is in period 2. So period 2, 2 shells. Because oxygen is in group 6, it means that it's going to have 6 electrons in the outermost shell. So we're going to count 1, 2, 3, 4, 5, 6. So 6 electrons in the outermost shell. Now remember, this one has got only 2 shells. And we said that those atoms which have got only 2 shells here are supposed to have how many electrons in the outermost shell to be stable? 8. And those electrons that need those atoms that need 8 electrons in the outermost shell to be stable, they obey the octet rule. Octet means 8. Those electrons which need only 2 electrons to be stable, they obey the duet rule. Duet means 2. So because oxygen only has got 6 electrons in the outermost shell, it needs 2 more to be stable. So already it means for it to have 6 electrons in the outermost shell, it means that it has got 2 electrons in the inner shell, because you can't end up with 6 electrons in the outermost shell if you have not filled entirely the inner shell. So this means that how many electrons in total does oxygen have? It has got 8. So these 8 electrons is also the number of protons. So oxygen has got 8 electrons and 8 protons. Now remember, the electrons are negatively charged, the protons are positively charged. So if you have got equal number of negative things and positive things, you end up with a neutral charge, because negative 8 plus positive 8, they are going to cancel out. That is why you end up with neutral atoms, they don't have any charge. So the meaning of that is that for oxygen to be stable, it needs 2 more electrons, because remember, the outermost shell only has got 6 electrons. So it is either oxygen loses the 6 electrons that it has so that it can only have 2 electrons inside, or it gains 2 electrons so that it can have 8 electrons. But it is much easier to gain 2 electrons than to lose the 6 electrons, because they are a lot. So oxygen ends up gaining electrons to be stable. And when an atom gains electrons, it becomes negatively charged. Because oxygen gains 2 electrons, we write it as oxygen 2 with a minus. That is because for it to be stable, it needs 2 electrons. Every time an atom gains electrons, it will become negatively charged. So in this case, we say oxygen is now an ion. What is an ion? An ion is a charged particle. So oxygen now has got a charge because it has gained 2 electrons. So oxygen that has got a charge is different from oxygen without a charge, because now remember, this oxygen has gained 2 electrons. So of the 8 electrons that it was supposed to have, it is now having 10 electrons. But the number of protons has not changed, they are still 8. So when an atom loses or gains electrons, the protons are not affected. Okay, so this is how it is going to end up. Are we good? All right. Now, okay, let me use another board here. So let's say here is sodium. Sodium has got 11 protons and then a mass number of 23. If you say an atom, the number mostly that is on top is the mass number. So let's say they ask us to say find the number of electrons, protons, and neutrons for sodium. Starting with the number of protons, the number of protons is basically the number that you see given here. Always the small number between the two is the proton number. That is 11. How about the number of electrons? Remember, for a neutral atom, the number of electrons is equal to the number of protons, so that will also be 11. And then the number of neutrons. When you add protons and neutrons, you're supposed to get the mass number or the nucleon number. Therefore, to get the number of neutrons, it will simply be 23 minus 11, and that is going to give us a 12. So let's write the electron configuration of sodium. What is electron configuration? Electron configuration is just showing how many electrons are in each shell. Remember the rules we talked about? The first shell can only have a maximum of 2. The next shell a maximum of 8. The next 18. So when you're writing the electron configuration for sodium, which has got 11 electrons and protons, this is going to be you first fill the first shell. The first shell can have 2 electrons maximum, and then you write comma. So we have from the 11 we have removed 2. How many are remaining? 9. But remember, the second shell can only have 8 electrons, so I'm going to write 8. How many are remaining? 1. And then I'm going to write that 1 at the end. So this is the electron configuration for sodium. Now, I need to have actually, as long as an atom has got more than one shell. If you write an electron configuration for like this one, it means that this sodium has got 3 shells. That's why you can see 281. It has got 3 shells. The way it is like this, as long as an atom has got more than one shell, it can't be stable when it has got less than 8 electrons in the outermost shell. I need 8. Now remember, we said that the third shell can have a maximum of 18 electrons. But to be stable for the first 20 atoms in the periodic table, it is going to have 8 electrons in the outermost shell. So what are we going to do? It is either you gain 7 electrons to make this one to be 8, or you lose this one so that you remain with this 8 here. Now can you tell me which one is easier? Is it to gain 7 electrons, or to lose 1 electron? To lose 1. So what sodium does is that it will be able to lose this electron. Because sodium is only losing 1 electron, it will become an ion. Every time a compound loses an electron, it becomes positively charged. Because it has lost only 1 electron, it is going to have only 1 positive charge. So the configuration remains 2, 8. So it has now only 2 shells. An ion that is positively charged is known as a cation, while an ion that is negatively charged is known as an ion. Ion itself is just a charged particle. If it is positive, cation. If it is negative, anion. That is important. So, let's say we are given, what atom can I even use now? Let's say we've been given nitrogen, and then we've been told it has got a charge of -3. They say find the number of protons, electrons, and neutrons. So the first thing is you are going to go on the periodic table which always be given. You check for the mass number, and you check also the proton number of nitrogen. Okay, so I don't have a periodic table, so okay, let me try to get one so that we use the actual values for nitrogen. Okay, so nitrogen has got a proton number of 7 and a mass number of, hope this is the correct one, a mass number of 14. Okay, there. So how many protons are going to be here? What do you think? What will be the number of protons in this atom? 7. Very good. Okay, so this one is going to have 7 protons. How about electrons? How many? Okay, 7. So you've seen that is where it changes, because this one is an ion, it's not a neutral atom. You can see a charge on top there, a charge of -3. And remember, if you have got a negative charge, it means that something has gained. So initially it was supposed to have 7 electrons, but because of that -3 charge, it means that this nitrogen has gained 3 electrons. So of the 7 plus 3, so it now has 10 electrons. And then the neutrons, remember neutrons is given by mass number minus atomic number. The mass number is 14, the atomic number is 7. Please never use the number of electrons unless if that atom is neutral. So this will give us 7 neutrons also. Does this make sense? Okay. If you look at the number of electrons of an atom, if that atom is neutral, it doesn't have any charge. The same number of protons is going to be the number of electrons. But when a molecule is charged, if it has a negative charge, depending on the charge, it means that this nitrogen has gained those number of electrons. So it has gained 3 more electrons. Remember, it was supposed to have 7, so it's now 7 plus 3. So if we had something like, let's say, oxygen, oxygen normally has got 8 electrons. It has got a mass number of 16. Let's say it is like this, it has a charge of -2. Or they'll just write oxygen with a charge of -2. Proton number is 8. The electron number was supposed to be 8, but because of that charge, it means that oxygen has gained 2 electrons, so it is going to have 10 electrons. Does that make sense? Okay, but if something is positively charged, let's say like sodium with a positive, normally sodium has got it has got actually a proton number of 11, but because of the positive charge, the electrons were supposed to be 11. But that positive charge means that it has lost an electron, so it's going to have only 10 electrons. So that is it. If you have got things like, say, magnesium, whatsoever the number of protons that this one has, to find the number of electrons, you need to remove a 2 because it has now a charge. Good? So let's write some electron configurations. Let's say I want to write the electron configuration of, let me try to get some atoms from the periodic table. Okay, so let's say we want to write the electron configuration for aluminium, and aluminium has got a proton number of 13. So to write the electron configuration, you always start with a 2 because the first shell can only have 2 electrons, comma 8, and then comma. So already we have used up 10 electrons, we are just remaining with a 3. So comma 3. So already this tells us that aluminum is going to lose these three electrons. And so because it loses, it forms a charge of positive 3. Because it was supposed to reach 8 to be stable, but gaining 5 electrons is harder than losing 3 electrons. That's why it ends up losing. So this is the ion for aluminium, and it is more stable than the neutral aluminium, like that. Okay, so that is how you can write the electronic configuration for this one. Let's say we want to write the electronic configuration for chlorine. Chlorine has got 17 electrons and protons. So the configuration is going to be 2, comma 8. So already how many have we used up? We have used up 10. So comma 7. Say we wanted to write the electronic configuration for potassium. Potassium has got 19 protons. So the electronic configuration is going to be 2, comma, the next thing is going to be 8 electrons. So we have used up 10 from the 19, so 9 are remaining. The next you write again 8. 1 is remaining and then write 1. That is why if you go on the periodic table, potassium is actually found in period 4. This is period 1, period 2, 3, and 4. Potassium is going to be found somewhere here. And it is in period 4, group 1. Group 1 means that it has got 1 electron in the outermost shell. Group 4 means that it has got 4 shells. Does this make sense? Okay. So basically this is on the atoms that you need to get for now. Another thing that I need to mention is the changes of state. Okay, because we are talking about atoms and states of matter. Now, matter, what is matter? How can you describe what matter is? Pardon? Uh-huh. Okay. So matter is anything that occupies space and has got mass. For example, you, where you are seated, there is a space that you are taking, and we can measure your mass on a balance. And then air also can occupy space. We can also measure its mass, so it has got mass. Now, there's three states of matter. We have got solid, liquid, and gas. These three states of matter can actually interchange amongst themselves or between them. But you need to know especially the arrangement of particles in these three states of matter. So, if you look at a solid, the particles are closely packed. Particles are closely packed, meaning there is no space for them to be able to move like that. Closely packed. When you look at liquids, liquids can flow. So at least they have got some space in them. Now gases, they are really freely able to move. They can move in any direction. So they have got total freedom. That is on the arrangement of particles. Solids, they have got particles closely packed, liquids they have got some space, and then gases are freely able to move. And then also you talk about the way they can occupy volume. Now solids have got a fixed volume. Let's say for example, if you have got ice, if it fits in a certain container, you remove it like that, it might not fit exactly in another container. Its volume is fixed, you can't change it. While liquids have got no fixed volume. Okay? They can take up shape of a container. If you put water in a bottle that is round, it will also take up that shape. If you put water in something that is triangular or a cube, it will take up that shape. Gases too have got no fixed shape. They can fill up a container like that. So because of these properties we've talked about here, solids are going to have a high density because particles are closely packed. And then liquids are going to have a low density, gases are going to have the lowest density. If you look at how sound travels in these mediums, sound will travel fastest in a solid, then in a liquid, and then in a gas. Actually, where there is no air, sound can't even travel in there. Okay, so these are the states of matter. Now, say we have got a gas here, and then we have got a liquid here, and then we have got a solid. Imagine you get water, you put it in a fridge, it will become a solid, and that is known as freezing. When you get ice, you put it on sunlight, it will change and become water back, and that is known as melting. So for freezing to happen, there is a loss of heat. For something to melt, there is a gain of heat. That's why you need to put it in light so that it can gain energy. Now, when you get water, you start boiling water, it will change into a gas. Okay, when you boil water, it will change into a gas. That is known as evaporation. The other term for evaporation is it has become vapor, so it is known as vaporization. Now, when you get vapor, remember when you are moving from liquid to gas, for it to become vapor, you are trying to heat this thing. So there is a gain in heat energy. When you get a gas, you cool it. Let's say, for example, gas, and then you put something that is cold to gas, or you put it in a cold place. It will become water again. And the change of state from gas to liquid, that is known as condensation. It has condensed. That is condensation. So here there is a loss of heat. When you get a gas, a solid, you convert it direct into a gas. Because normally for you to convert a solid to a gas, you first need to convert a solid into a liquid and then a liquid into a gas. But a direct conversion of a solid into a gas, that is known as sublimation. And the only way you can convert a solid into a gas is when you add heat. So there is a gain of heat. The conversion of a gas into a solid in the opposite direction, this is known as deposition. Okay, so you need to take note of that. Are we okay? Are we good? Okay. Now, maybe what are some examples of things that can undergo a direct change from a solid into a gas? We know water can go to a gas as a liquid and into a solid, but what are some things that can go direct from solid into a gas? Sublimation. So you have got things like iodine, because I've seen some questions like that. Ammonium chloride. Yes, not everything can convert direct, because if you get water, it will not change direct from solid into a gas. It will first go from solid into a liquid and then into a gas. You have got also dry carbon dioxide. So these are some things that can undergo direct conversion. Dry carbon dioxide, also dry ice, this can go undergo direct conversion. In case they asked you in an exam to list some examples. Now, this concept I'm about to mention is very important for you to understand. When you are talking about these changes of state, for a change of state to happen, remember we have said there is either going to be a gain or a loss of heat. So we have got what we call the heating curve and the cooling curve. Let me start with water, with a heating curve. So this is going to be a heating curve. Let me also write in advance also a cooling curve. This they like bringing it in the exam. Now let's say we have got ice, and that ice which we have is say at negative 10 degrees Celsius. So this is going to represent temperature. The y-axis is representing temperature, and then the x-axis is representing the way the reaction is progressing. So we have got ice at negative 10. Because this is a heating curve, when you start adding heat to ice at negative 10, the temperature will start rising. Temperature is rising. Temperature is rising. When you reach at 0 degrees, this is known as the melting point of ice. So at this point, ice will start to melt. Now, when ice is melting, the temperature will no longer be changing. Look at the line. The line has become flat. So at the changing point, we call it the hidden heat. We'll talk about it very much in physics. It's known as the latent heat. It's hidden. Okay? So here, remember, you are the solid. Now at this point, this solid is converting into a gas, because a melting, I mean, is into a liquid, is melting point. So when all the ice has melted into liquid water, then if you continue increasing the temperature, now the temperature will continue to increase. So now what you have here is, no, you don't have any ice. you have got only liquid. At this point, when ice is melting, there is actually a mixture of solid and liquid. Remember, when you get your ice, you put it in the sun. As it is melting, you are going to see ice inside and you are going to see water because it is still melting. And at this point, this is where we have got a change of state known as melting. So when every solid has melted into the liquid, the temperature will start rising. For water, when you reach 100 degrees, the temperature will stop rising anymore. So it levels off. At this point, you have started converting your liquid into a gas. When all the liquid has been converted into a gas, then you can now have your gas. So at this point, you have got a mixture of liquid and gas. And that point where a liquid changes into a gas, that is what is known as evaporation or vaporization. So at 100 degrees, where you can see this is known as the boiling point of water or the boiling point of a substance, because that is the point in which it is changing into a gas. So they can ask you in the exam, what happens at the boiling point? What happens at the melting point? So at a point when there is a change of state from one state of matter to another, temperature does not change. A compound is gaining heat, but you will not see any change in temperature. That is why you can see this straight line. So that is what happens. Now to go the other way around, that is a cooling curve. Let's say you have got a gas which is at 120 degrees. When you start removing heat, because this one we were cooling, when you start removing heat from this gas, you can see the way it is dropping like that. It's dropping. When you reach at 100, say here is the 100 degrees. When you reach at 100 degrees, the temperature will stop to reduce anymore. So at this point, you are changing this gas into a liquid. So after all the gas has changed into a liquid, the temperature will continue to drop. So this is now a liquid. And at 0 degrees Celsius, this is a point where the changes of state is going to be happening. When you reach 0, if this was water, the temperature will stop again changing. Because now you are converting this liquid, you are now freezing it. It will go into a solid. So at this point, when you are converting a gas into a liquid, this is known as a condensation. That's a change of state happening. You can see there is no drop in temperature when a change of state is happening. And then at this point, when you are changing your liquid into your solid, that is known as freezing. So this is the melting curve and also the heating curve. You need to make sure that you know this because they can ask you to draw or they can bring it and then they ask you to label and answer questions from it.